Hello everyone. In this video, I am going to discuss about the free body diagrams with some simple examples. Why actually anybody need a free body diagram? So any object, whether it is stationary or it is moving, it is subjected to different types of forces. So, in order to analyze these forces, we need to first of all draw a free body diagram. So, in this particular So we need to for drawing this free body diagram, we have to remove all the objects which are attached or supported or in contact with that particular object, and then replace all these surfaces or the objects which are earlier in contact with this particular surface with the corresponding forces. Okay. So now let us see first of all a simple example like a block which is resting on a table, right? Which is the first and very simple example, fundamental example you can say. Let us say it is having a weight W and it is resting on a table. So first of all, we need to write how to draw the free body diagram for this one. What are the different forces that are acting on this one? So if you draw this particular block, what is the weight W? How it is acting, this weight, because of the gravitational force, always will be acting in the downward direction, that is W. So if only this W force is acting on this particular block, it should be dropping down, it should be moving towards the earth, right? But this is not the case, it is resting on this particular table, right? So therefore this table is exerting a force on this particular block, which, because there are no other forces that are acting on this one, it must be acting in the equal and opposite direction to this one. So this force which is exerted by the table on the block is acting in the upward direction like this, right? So let us say, because this is acting in the perpendicular direction to this particular one, or we consider it as a normal reaction or normal force, we can denote it by Fn, or sometimes we also denote it by the normal reaction, right? So these are the two forces that are acting on this particular simple example. So now let us see another example, right, where a particular, again let us take a block which is of weight W, but it is held by a string. It is hanging in the air with the help of this particular string. Let us say like this, right? Then what are the different forces that are acting on this one? This is example 1. Of course, this is example 2. So what are the different forces that are acting on this one? Again, we know that the weight W is acting in the downward direction like this, right? Then what is the other force, or what are the other forces that are acting? If you see this one, this string is holding the block. Other than that, there is no other object or surface is in contact with this particular block. So the only other force other than the weight of the body is the force exerted by this particular string. So this force will be, because the string is in this direction, it is holding this block. So there is a tension acting in this particular rope because of the weight of this block. So we have a tension in this particular rope which is acting in the upward direction like this, right? Tension is acting in this direction in the rope. So these are the two simple examples. So let us see another example, right? Like a combination of different forces. Let us see. Let us say again this block is resting on a table like this. Still, we are talking only about the static forces at present, right? We are talking about the blocks which are stationary right now. There is no movement, no velocity, no acceleration for any of these blocks. We are talking only about the stationary blocks. So let us say this block of weight W is resting on the table. and there is certain force is acting on this particular block, let us say to the right of it, right? Let us say it is some force F, right? Some force F is trying to pull this block, horizontal force is trying to pull this block in this particular direction. So, what are the different forces now acting on this block? How to draw the free body diagram for this one? So, this is the block and the weight is acting in this direction, W, right? Like earlier cases. And now the force, and also of course because of this particular surface on which it is resting, like table, right? There is a reaction, like the first case, normal force, and this force F is acting in this direction. So now because the block is stationary, right? So there must be some equal and opposite force that acting in the other direction to this force. So these two are balanced. So this also has to be balanced with some other force because the block is still in the rest position. So what is that force? It is the frictional force between the block and the table, right? On the surface on which it is resting. So that frictional force, how it should be acting? It should be acting in the opposite direction to this particular force F. So it is frictional force, right? So let us say F, maybe you can say FF, right? Frictional force. So this is the free body diagram, which are there are four forces that are acting on this one. One is the weight of the body, normal reaction because of the surface on which it is resting, and the force that is trying to pull this block in the right side direction, and the one which is opposing to the movement of this force, this particular block, this force is frictional force, right? So now let us see another example, right, where you have a block like this. Again, I'm sorry, this is a surface and on which the block is resting with a weight W, right? And now it is subjected to a force F in the inclined direction like this, F, right? So let us say this is making an angle theta with the horizontal surface. Now what is the free body diagram for this one? What are the different forces that are acting on this particular block? Let us see. So this is the block. Again, as in the first case, the weight W is acting in the downward direction and the normal force is acting in the upward direction. Then what about this F, which is acting in the direction at an angle theta to the horizontal, right? Now we can resolve this into two components. One is the horizontal component, other one is the vertical component, which will give us actually it will be easy for us to analyze if you have forces in the horizontal and the vertical directions or x and y axis, you can say in general, right? So now what are these components for this one? F can be considered as F cos theta. I hope all of you are familiar with resolving the forces. Then F sin theta, right? So now the force F is one component is acting in this direction, that is F cos theta, and then F sin theta, right? And then again, because unless otherwise specified that it is moving or it is a smooth surface, there will be always a frictional force here. So we have a frictional force here, right? So this is the free body diagram for this particular case where you have a downward force because of the weight of the block W and upward force Fn because of the normal reaction given by the surface, and F sine theta, which is the component, vertical component of this force F, and F cos theta, which is a horizontal component of this force F, right? And then we have a frictional force which is opposing this particular movement, right? Because we are considering the block to be still stationary. We are not having any velocity or accelerations or any other forces that are acting on this one. So today, in this particular video, let us close with this discussion. In the next video, we'll see some more examples like block resting on an inclined plane, or some other complicated cases, and also some more examples. Goodbye.